Hi, good morning, good afternoon, and good evening, everybody, because people are joining from different time zones. So, myself, Pravi, I'm the instructor for this course. This course is a Wireshark Basic to Advanced training. So, this is day one. So, before that, let's quickly do a self introduction about everyone. I mean, we'll get to know each other because we are going to do this training for almost 2 months. So I think we should get to know about each other, what you do. A brief introduction about yourself would be fine. Not an interview, just I mean, to get to know each other so that it works better. So you guys can volunteer yourself and you can give an introduction about yourself, where you're from and what you're working for. I gave mute permission for everyone. Hi, Prashant.
Yeah, hi, Praveen. How are you?
Yeah, I'm doing good. Thank you. How are you?
Yeah, I'm good. So, yeah, I'm Prashant, and
Yeah.
I'm from Uttarakhand, and currently I'm living in Bangalore for the job purposes, and currently I'm working in Cognizant
Oh,
and
cognate.
networking domain. Yeah,
Networking domain. And you work for routing and switching?
yeah, routing, switching, F5,
Okay.
input multiple technologies I'm working. So,
Okay, FI, info blocks. Okay. You work on DNS, load
yeah,
balancers. Yeah.
yeah.
Okay.
So, and SD-WAN also.
Oh, SD-WAN. What kind of SD-WAN you guys are using it?
Sil
It's
Silver Peak.
Silverpeak, Aruba.
Yeah.
Okay. So how about your Wireshark experience?
Not much actually. It didn't work yet. So actually,
Mm-hmm.
we don't have allowed to install Wireshark in our system. So
Oh, is it? Okay.
yeah, but learning from my knowledge
Okay.
in case in future it requires. So
Mm-hmm. Okay.
yeah,
That this is a very essential tool, I think.
yeah, correct.
Yeah, we can install. There's no harm in installing this. This is just we are capturing the packets. Yeah.
Yeah,
Okay. Nice. So I'll move on with the next one, Prashant and the Shweta.
Yeah. Hi, Praveen. Hi, everyone. So
Hi,
myself,
Shweta.
Shweta,
Yeah.
and I'm working in Artson. And we'll be working on different things like we'll be working on routing and switching.
Hmm.
And also we'll be taking care of PA, Palo Alto. And
Okay.
I don't have much experience with Wireshark. That's the
Okay.
reason why I just want to
Hmm.
explore something over here.
Okay.
That's all.
Cool. Okay. Sure.
Thank you.
No problem. Yeah. And who's next?
Hey, hi, my name is Setu Raman.
Hi,
So
Setu. Yeah.
I work in network security technology. I am the
Okay.
network security background, mainly the firewall, Zscaler, and FI. So
Okay.
I used to troubleshoot using Wireshark for firewall troubleshooting and FI, but
Okay.
I have only very basic, not
Hmm.
much. detail.
Okay. Sure. No problem.
Thank you.
Thank you, Setu. Yeah.
Yeah, hi, Prashant. Oh, sorry. Hi, Praveen.
Praveen.
Sorry.
Yeah. 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 No problem. Yeah. Yeah. Akshay. Hi.
Yeah, uh, I'm working in Capgemini, so I'm into this routing switching. So I'm currently
Okay.
working as an consulting engineer for
Hmm.
client Cisco. So
Okay.
yeah, so earlier means so I have just seen some Wireshark captures and all those stuff,
Hmm.
but
Hmm.
not really completely. Only I have a basic kind of knowledge I
Hmm.
have, so I
Okay.
just wanted to improve, deep dive into that, and it will help me to understand the packet analysis and improve my troubleshooting skills as well. So will help me.
Okay.
So yeah, that's why I joined this course.
Okay. Cool.
Yeah.
Cool. Okay. So still anyone else is still pending, as in Tuan, Nilesh,
Yeah,
or
hi. Hi, my name is Nilesh. I'm
hi
working in,
Nilesh. Yeah.
yeah, hi. I'm working in network security and other fields. So
Mhm.
right now I have to improve my knowledge in this Wireshark part
Okay.
because daily troubleshooting and everyone's doing this Wireshark capturing
Mm.
TCP packets, UDP packets, and doing some troubleshooting and get the good result. So
Mhm.
I'm trying to improve my knowledge.
Okay.
So yeah.
Got it. Okay, Nilesh. Yeah, sure. I hope you will
Yeah.
definitely learn
Yeah, thanks,
something.
man.
Yeah,
Yes,
here.
yes.
Yeah. And I think it is Tuan and Vital Patel.
Sorry, hi everyone.
Yeah.
This is Patil. I
Hi,
having
Vital. Yeah.
I thank you. Yeah. Hi everyone. I having around 17 year experience in network and network security domain.
Okay.
And presently I'm working with the State Bank of India project.
Okay.
Yeah. So I have hands-on routing, switching, firewalls,
Okay.
and the load balancer.
Okay.
Not expertise in the Wireshark. I want to learn a Wireshark, packet capture logs, and all those things. So that's
Okay.
why I'm joining here. That's it from my end.
Mm-hmm. Got you. Okay.
Thank you.
No, no problem. Sure. Tuan?
Yeah, I'm Santosh here.
Santosh. Hi, Santosh. Yeah.
Hi, Praveen, and hi, everyone. I'm working in a Kindle for one of the leading bank,
Okay.
and I'm working in the load balancer as well
Okay.
as L7 inspection of WAF.
Mm-hmm. Okay.
I want to certain cases I am stuck with troubleshooting. I
Mm-hmm.
want to prove that whether it is the application end issues or the network end issues. So only I am joining here.
Mm-hmm. Okay. Got you. Cool. Um, Tuan is someone I think still Tuan. Okay, so if you guys still want to introduce yourself, let me know. So I'll give you a brief introduction about this course and where I'm coming from. So I started this capturing maybe 4 5 years back. Even I had the same kind of problem, and not a problem, I would say. I didn't get a proper clarity on what the Wireshark does and how do I start with. So this course is specifically designed from the scratch. If you know, we all know that the packet flow in most cases, most engineers they struggle in finding the flow of packet. If you have your network design, but they don't have the complete understanding of how this packet flows from A to B or from your host to internet. So for that, yeah, the solid foundation I feel is you have to start from your layer two. So we should know what is layer two, what is layer three. So when we talk about layer two and layer three, mostly we talk about only the MAC address, but there are more than that in layer three. If you look for this, there are multiple IP options. And if we are using a QoS, there is a QoS markings. We are not going too deep about routing and switching, but the most generic, the essential elements of packets. That's something we will look into this. I mean, we will be working on and we'll be learning. On top of that, we'll go layer by layer. We'll peel off every layer. We will learn that and we will do a lab. So this is mostly a 20% of whiteboard and 80% of practical. So people from a different background, I mean, if I say different background, you might be coming from a security team, routing and switching, cloud. So your IP packets remain the same forever. And here today we are going to see what are all the IP headers we have, why should we know that, and how exactly it works. Even though if you guys know that, we'll be looking in little deep. And the the main focus is for Wireshark. So we are doing that, and in the Wireshark, how we are going to interpret those values and how do we see that And we can relate this to the real-time troubleshooting. So I think it helps everyone to understand better the missing gaps. I think you guys will get an answer today. So let me start this. I hope you guys can see my screen, yeah?
Yes.
Yeah,
Okay.
it's
So since I don't want to interrupt this training, how it works, I'll tell you. So we will take a topic. We will do a explanation theory session, 15 minutes. We'll do practical 15 minutes. Then whatever the questions you have, please note down. Maybe if you have a piece of paper or whatsoever works for you, you make a note of it. And then we will discuss about your doubts and we will clarify your doubts. So we'll make it as a 2 session today. First half, as I said, 15 minutes, not 15 minutes theory, 10 minutes theory, and 20 minutes practical. Then we will do a Q&A session, and then we'll move to the second topic because this is a day one. From day two, it is a complete, what is that? I will be teaching you, as I said, maybe 15 minutes of theory and 45 minutes of practical. Altogether, it's 1.5 to 1 hour 45 minutes to 1.5 hours. It depends on the topic. After that, we have a session for Q&A. So let's see how it works. So we will discuss this together. If there is any changes needed, we can work on it. So now, because I don't want to interrupt this session in the middle, we have to go in a flow so that everybody will be keep following me. So I'm going to keep you guys in mute. So after 20 minutes, after I finish this topic, I'll give a new permission for everyone for a Q&A session. In the meantime, as I said, make a note of your questions. Yeah. So understanding the IP packet is very essential. We all know that how IP packet is and what is IPv4 and IPv6. But how do we relate this with Wireshark? Um, 1 minute. Let me take my whiteboard. Okay. So let's take a very simple example. We all know this, but let me do this. A whole new different whiteboard here. So the main component, we all know this, irrespective of your firewall, the very traditional network design. So let's take this as VLAN 20. This is VLAN 20. You got your firewall here. Palo Alto. So in most design, when you design a network like this, I have seen for a perfect routing, we all do the inter-VLAN routing, especially when you're using a design like this. When you have your firewall, when you have your load balancers connected here. So example, this is a VLAN 20, this is a user. VLAN 10, we can say it is used for management. So mostly all these ports in the switch would be the access. This is necessarily, you don't know. I mean, if you're from a different background, you don't want to know about this, but to capture the packet, it should be an access. And if I make as a VLAN 10, so this is going to tag my packet only for VLAN 10. Correct. So this IP communication within the switch, if it happens, we say this is an inter-VLAN routing. For example, you have a firewall here and I have a VLAN 10, interface VLAN 10, and I'm assigning an IP address 10.0.0.1. It's on the switch here for VLAN 10. And I got a firewall here and make it as an access port. I'm connecting this management interface. Do I need a routing? If there is a problem, it could be a routing issue or what it could be. So this traffic is not passing through the firewall. This is an interface communication between the Palo Alto and the switch. So this traffic is not passing through the firewall. Only then it goes for the inspection, whatever we are discussing about. So in some use case, or maybe there is a design like this, and you may have a problem, this Palo Alto management IP addresses is not connecting to your wildfire. So this is purely we can isolate. We are not looking into layer 7. It is purely a layer 3 problem. It's my routing problem. But how this Wireshark helps me to find that, right? So for that, we should have a little more better understanding about TCP IP, because your TCP IP is a building block for your whole Wireshark. I mean, not only TCP IP, we use UDP, but predominantly I'm saying most of the application, they use TCP IP. So here, let's take a very, very simple example. We got a PC, you got a switch. You got a switch. Here you got a server, you can name it as a server. This is a client. So this is one simple connection to the server. I want to see, can I do an SSH? So when I do one SSH, it uses the port number 22 from the client, right? So you can use any kind of application. You can use your PuTTY or any remote terminal application you can use to establish your connection. So what is that you should understand better and what you should know? First thing comes here. First, you should have a routing. The packet should be routed, right? And then comes your TCP. So when I say TCP, we should understand that is a peer-to-peer communication. What is the meaning of that peer-to-peer communication? So it can be a switch. I can have an ACL to block this traffic, right? For if I say this is a peer-to-peer communication, when a connection establishment happens here, when the SSH has to work, first your TCP connection should be successful. It's label here, right? The routing, your TCP, then comes your application SSH. This is layer 7, right? So what we should understand here, before doing a troubleshooting, we should be very familiar with this TCP three-way handshake. So the very first packet, what it's going to send, it's a TCP SYN. We know that, but this is called as a 4-tuple connection. First thing, source port, source IP, destination port, and destination IP address. So what is my source port? It is a randomly generated port by the operating system. I have no control about that. So let's say it is 56023. My source port would be 10.0.0.1. This is in VLAN 10. This is in VLAN 20. So inter-VLAN routing is happening. So DP destination, sorry, the source IP is 10.0.0.1. My destination IP here, it's in VLAN 20, 20.0.0.2, 20.0.0.2. What is this destination port? 20T, sorry, 22. This is a standard port. We can't change anything. So for the successful communication, we should not block this particular port in the server end. So this port 22 should be opened. And now we'll discuss this in the lab, no worries. So what could be the problem here most of the time? You may encounter in two problems. This is your PC and this is your server. It can be ACL can be filtered. Your packet will be filtered so that you can't establish your connection, or you don't have a route. Two problems. If you have a route but still you can't establish a connection, is it something ACL or something is blocked? So how do I see and find this in Wireshark? Retransmission. It proves I don't have a routing to it. Then if there is a port is blocked, I should see reset packet. These two packets I would see apparently when there is no successful communication. As we do in the firewalls, policies, NAT, in the same way in the Wireshark, you should understand all this key elements. So when you see retransmission, you have to look for your route. Also, it can be your problem with the layer 2 or layer 3. Example, if this particular server is on VLAN 20, and this is on VLAN 10, then maybe a misconfiguration with VLANs. Or maybe there could be a problem with the routing here. It can be any hop, but the whole objective is to find where is the problem. It could be, if there is a retransmission, it could be a layer 2 or layer 3 problem. And if there is no retransmission, you don't want to look about your routing. You have your problem with reset. So somewhere it is blocked. And when I say it's a peer-to-peer communication, it is always between source and destination, a direct connection. So whatsoever in the middle, they can just block the port. They can't do anything else. So what are the possibilities here? Either my source would block this traffic, or the destination can block this traffic, or anything in the middle can block this traffic. So we'll see this practically. You'll understand this better. So this is the topology we are using here. It's a very, very simple topology. I have this Palo Alto firewall here. I got a switch and I got a router. Let me take this. And so this is used for my external connection. This is for my internal, and this is used for my management. All these ports are access ports. Let's try this scenarios now. So I've created an inter-VLAN 10 switch virtual interface. We say that this for routing, layer 3 VLAN. So here this is, I have a Kali Linux box for testing. So I have connected this port GI0/3 to Kali Linux. From this, we'll establish some traffic here. I'm going to check the interface of Kali Linux. Let's do a config GI 0/3. So I'm going to do this as an access port. So I'm going to allow only VLAN 10 on this GI 0/3. There is a purpose. I'll tell you why we are doing that. Let me go to this Kali Linux box and let's see the IP config. It's not maximized. Okay. So 10005 is assigned for this Kali Linux. So let me go back to terminal. Okay. So now show IP interface brief. I'm going to shut down this interface. Why is this? I should have one more terminal, a bigger terminal for it. So I see the traffic going on this 10005, right? So I'm going to capture the traffic on it. So it's trying to reach all these IPs. So what is the IP we are interested in? Let's go back. Let's ping 10001. So I'm on the switch. I'm going to check the show IP interface brief. This is admin down. I'm trying to reach 10001. I go to Kali Linux. So what is the filter I should use? I'm trying to reach 10001. So IP dot address equal your actual IP address 10001. So my source, if you look for the layer 3 packet, my source 10005, this Kali Linux box has been assigned with this IP address. It's trying to reach 10001. But what is the reply I got? I have keep sending this ping request, but there is no response coming back. So if I try to do, how do I initiate this retransmission package? So far we are dealing only with layer 3, and now we are trying to initiate a traffic for layer 4. Can you guys make a note of this, or if you know the answer, why we don't see any TCP traffic here? Let me go back to the switch. So this is a topology. Now we are in the switch. I'm hopping back to this call Linux again. So I turned up this particular interface. We got this inter VLAN 10, that's for routing. And this particular port, as I said, it's for VLAN 10, access port VLAN 10. Let's go back to the switch. So IP interface brief, loop, assign. Go back to Kali Linux, go to the prompt. I can ping now. If I go back here, so now if you see, I see ping request and ping reply back. So what are the key values we will see inside? I'll come back to this. So now, let's see if I try to initiate a traffic now for TCP. So now I see the TCP. So, okay, we'll get back to that. So the source 10005, this call Linux is trying to establish a connection to 10001, and I'm trying to do this on port 443 because I'm doing a HTTPS there, and I get a reset. So who is resetting this connection? 10001. So this is a flow you should understand. So when I send a SYN from source to destination, I expect the SYNAC back from source to destination. But when I send a SYN, so what are the key values we should understand here? In the TCP, the source port is 443. Who's doing this? This is destination IP address 10001, right? When we go for the first packet here, 10005. So I said it is a 4-tuple connection. So my source IP is 10005. You see the source address 10005. Source port is 40,900. And this is a source port, and the destination port is 443. And what is my destination IP address? It's 10001. So it's between the Kali Linux box as a source and the interface VLAN 10. Since I don't have a routing, I don't see the retransmissions. I don't see a reset packets. So here I have a routing, and this Kali Linux box is trying to establish a TCP connection on port 443. Since the 443 port is not enabled, or we are not running any kind of service related to 443, I get the TCP reset. Who's sending this? This is 10001 is sending to 10005. So what would be the successful scenario? If I have a successful connection, what should I see here? And what are the other key elements I should focus on when I'm troubleshooting? So for that, I'm going to the switch. So I'm going to create a username and password. The commands can be different. You can use a different platform. We are just focusing on the idea. So let's go back to this Kali Linux box and let me see if I got something like a putty. I think it's natively supported. So from 10.0.0.5, I'm trying to establish a connection. Again, I don't see the three-way handshake. It resets the connection. Let's see why it happens. I don't know whether we can do a telnet from this box. Let's try. So now if I go to Synac. So I'm interested in this packet, Synac packet here. I mean, in the whole TCP dump, if I want to look for one specific packet, because see, this all reset packets. Here I saw the Synac back from 10.0.0.5 to 10.0.0.1. So let me go conversation filter, and if you go TCP, the very first value you should see is SYN. If you look at the SYN, Synac ACK, three-way handshake happens, right? Come back. Okay. So this is source and this is destination. Source port 42554 and the destination port is 23, and 23 is responding back to this source. And here your actual telnet data is being exchanged between the source and destination. So now let's see the retransmission scenario. Let me go to the Kali Linux again. The capture is still running. Now do a telnet 10.0.0.1. No route to the host. That's Kali Linux is telling us. What is this? Let me take a fresh capture. Go here, open the Wireshark. Go to this interface. This is 10.0.0.5. Going to the command prompt. Trying to do a telnet. Doing a telnet. Then again, I'm going to shut down the port. I want to establish a connection first. Then I'm going to break this connection purposely. Okay. So if you take this packet, so 10005 is trying to establish a connection. Since there is no route, you can see this retransmission. So when retransmission happens, I have established a connection, but there is something broken in the destination. So for now, I know my routing is good. My VLAN configuration is fine. But if I establish a connection, I have a connection, successful connection in the beginning. I have seen my three-way handshake. So that proves my source port and destination ports are opened. The peer-to-peer communication was successful in the beginning. There is something happen in the middle, maybe a file. I mean, there is something happen in the middle. I mean, that's something broken in the middle, or it can be an ISP. But the retransmission, when it happens, you had the successful connection before and something happened in the middle that broken your connection. That's when you see your TCP retransmission. And you know that if it is a reset, this particular service is not running, or it could be the port is being blocked, either in the actual destination or a device in the middle. But the whole logic is how we can use a Wireshark to understand this better for troubleshooting the different elements of TCP. So your TCP three-way handshake is very important for this. So now let's talk about the ARP. So that's very key component, I would think. That's very important to understand, because most of the scenarios I have seen, we will end up with a problem with routing, but we don't know how to figure out exactly where the routing is failing. Yeah. And along with that, we will first deal with the whiteboard explanations for IP headers. Let me open up the PowerPoint for it. So inside the IP packet, what are the key values I should see? So we're going by layer. So in the topic today, we are going to discuss about the IPv4 packet header. So we will see what is the version number. Then you should see your time to live, TTL. We'll discuss that in some time. What is the TTL? So we use this. We all know the source address, destination address, and some of them you might be using your TCP IP options. We'll discuss that. But let's cover the basics, and then I'll tell you what we should do for troubleshooting. What are the key values you should look in your IP header? So I used to look for the TTL. That's more important. I'll tell you in which scenario TTL is so important and why we should understand that. To understand the TTL, we should also understand the ARP, how it works. Then the identification number, that's very important. It's like a stamping your every packet. If I send 4 ICMP packets, if I send 4 ICMP packets, you send 4 ICMP request, I should get a reply back. So say, for example, in my ping request, my first ICMP is 1201. This is called an identification. My second ICMP, 1202. Third ICMP, 1204. And we have no control about this. This is all generated by the operating system. This is something we can understand the packets, how it is marked, so that we can find the missing packets. Well, why this particular packet is missing? What is missing? So TCP identification is used for that. And apart from that, we will see if I do a specific block, if there is a different ICMP codes. Example for the host unreachable. If the host is filtered, if they're blocking the ICMP, you will see something like a filtered option. right? And in your actual payload is your ICMP payload, right? In the layer 3, you're not going to send anything more than your ICMP packets. It's all about where I should route this packet, who is source, who is destination, what is my TTL, is it IP version 4 or IP version 5? And also we will deal with fragmentation. That's very important. Let me delete this. Okay. So let's see this practically. How do we see that? And before that, let me give you um, a quick glimpse about the ARP. So we'll see the very simple ARP, two use cases, one within the same broadcast domain. And this is between different broadcast domain. So example, in your switch, you got your PC like this, and you got your firewall, and it can be your load balancer. And you are using a common management VLAN for it. VLAN 10, this is also VLAN 10, only for management. And this PC is connected to VLAN 20. So this is 20.0.0.4. So we'll take one PC, that's fine. So here it is 10.0.0.2, and this is 10.0.0.5. So when 10.0.0.2 wants to talk to 10.0.0.5, how this ARP works and why we should understand the ARP. And in the Wireshark capture, what should I see in the ARP? ARP request from the source, ARP reply from the destination. And apart from that, what is inside the ARP? That's important. ARP request is a broadcast. ARP reply is a unicast. So in this example, this comes with the firewall comes with the source 10.0.0.2. An IP communication between these two, load balancer and this guy on management VLAN 10. So this guy is just routing the packets between the same VLANs. So this is a switch, and you got the switch virtual interface SVI interface VLAN 10, your layer 3 VLAN, and it got an IP address 10.0.0.5. So when I ping from 10.0.0.2, 10.0.0.2 source to the load balancer destination 10.0.0, can't write it, 10.0.0.5. What do you guys think? I mean, you might know this answer very well. It never goes for your default gateway and goes direct to this. But what is exactly happening in the background and why we should understand this? In the whole network, the complete packet flow, right? When you do www.google.com, your router, and this is your cloud where you got this 8.8.8, your DNS connected. So if you understand this logic of ARP, you will understand everything. So that's mostly frequently asked question. I mean, when I do www.google.com on the website, what happens? So we are not talking about that. We are just focusing only on the R because today we are learning only about layer 3 headers. And we will compare this and how we do that in the Wireshark. Yeah. So as I said in the previous scenario, you got a different device, a firewall here on VLAN 10, and this PC is on VLAN 20. Now we are just talking about the IP in the same VLAN and how ARP works. So the default gateway has no role to play when it is a communication between within the same broadcast domain, I would say. This PC is trying to establish a connection with PC2 on VLAN 20. Yeah, the communication establishment happens and how this ARP works. So first it will send the ARP request, whom this PC1 will send the ARP request PC1. What do you see in the ARP packet? Source IP. Obviously, this PC got an IP in the 20 segment 20.0.0.4. Destination IP. We know the destination IP. This is a PC2. It is, let's take it as 20.0.0.5. An example, in the replication, we'll see the availability of VLANs, but the logic is same. So it's 20.0.0.4 talking to 20.0.0.5 here, this device. But inside the R packet, your layer 3 will be a broadcast 255, 255, 255, or 255. Layer 2, all F. This is for destination. And what about for source? This continues here. For the source, it gives the MAC address of the PC. That is example, let's say AA. And destination MAC is a question mark. I don't know. The whole point of R in every hop is to find the destination MAC address. That's the whole logic of it. So what if this PC1, let me take a different color so that stands out better. Let me take green. So this PC, VLAN 20, wants to talk to VLAN 10. So there should be a device that should perform a routing. Because within the same broadcast domain, I don't need a default gateway. Why? In the R packet, if I do a broadcast, this is local broadcast, right? So it happens only within the same network. The broadcast never crosses your network. So when I say same network, here I'm talking about VLAN 20. So when I do a broadcast, apparently this guy, raises his hand and it's going to tell I'm 20.0.0.5 and you are looking for my MAC address because you know the destination IP address, but you don't know my MAC address to forward this packet, right? So what is the theory of ARP? So when ARP broadcast happens, except the incoming port, it's going to flood this packet out of all the ports. And as I said, this broadcast is only local. So VLAN 10 will not get this broadcast. Only this PC will get this broadcast packet, not this guy. So what happens? I don't want to go to the gateway. So I get the ARP reply back from 20.0.0.5 to 20.0.0.4 directly. And it's going to tell my MAC address is BB. And here I'm going to fill BB, and this packet will be forwarded from PC1 to PC2. This is how your ARP communication happens. Let's do this practically. Let's see. So now in this case, show IP ARP. So IP interface brief. So let me connect one more computer to this on the same VLAN. Let me take normal device. So I want to make a communication between this Kali Linux box and the normal VPC device here. So port 1/3 and 0/3. I don't see why I don't say this 1/3. Okay, I did only the shutdown. Which port access VLAN 10. So VLAN. So GI 0/3, 0/3 connected to Kali Linux box and 1/3 connected, and this is a switch. The routing is happening on VLAN 10. This is a layer 2 VLAN we have created, and I'm going to show up interface brief, exclude unassigned 10.0.0.1. So I'm going to assign an IP address for this VPC box. Happening here. So IP address 10.0.0.20. Subnet mask 255, 255, 255.0. You can follow this. If you give a question mark, you can do in a multiple ways. So I'm using this method. I'm giving an address and I'm giving the mask, and I'm doing the gateway. My gateway is 10.0.0.1. So can I ping 10.0.0.1? I can ping. Okay, so now let's go to the switch. Okay, let's do a debug in the Wireshark. So let me go here. I'm going to the switch, and if I'm going to see the ARC packets here. This is for 20, and this is for 5, and this is 1. This is local. This is my VLAN 10. This is a Kali Linux box. This 20 is the new device, a test device we have connected now. So now to flush this ARP to test, and first let me see if I can ping this device. Is it pingable between source and destination? Let me go back to Linux. If I ping 10.0.0.20, I can ping. Oh, let me go back to the switch. And if you want to really flush all your ARP, you have to go to the interface. So now I don't see an ARP entry for these two. So there's no MAC address. It's been populated here. So my IP communication or your any connection, you have to trigger the connection. Only then you can see all your TCP traffic or your IP routing and everything. So I'm going to this Kali Linux box and I'm going to open the Wireshark. So let me see only for ARP packet here. Ping 10.0.0.20. So I got this packet. I minimize this. So if you see this here, this is an ARP request. This is the source and this is the destination. I'm looking only for ARP. Let's see the ICMP, but we are just looking into the ARP packet. What do we see inside the ARP? So if you see this, center MAC address, I think we have to take a different caption. It's a target MAC address, target IP address. I should not see this output. This happened before what? This reply. 1 minute. Let me do this again. Do we see any other ARP packets? Give me 1 second here. Yeah. Okay, so in the ARP, what are the value we if you look at this is an ARP request, right? So in the ARP request, we know the sender MAC address. We know the sender IP address. If you go through this, okay, we cleared this. So only thing is in the ARP, which is something we don't know where it is the MAC address we are looking for. We don't know this MAC address. So this device is connected here. There's a switch in the middle, but I don't know the MAC address. And without these details, this packet cannot be forwarded back. So who is responsible for layer 2? So this guy will do the forwarding based on the MAC address. But this packet is destined for this VPC, but I don't know the MAC address of the device. Correct? So in the ARP request, this is the sender MAC address. Correct? The sender MAC address is this guy, 10005. And I don't know how to see this here. If config. If you see this 1A:00, last 4 digit. So this is sender MAC address, but I don't know the destination MAC address, but I know the destination IP, but still I can't forward it. So who replied for my ARP request? That's a layer 2 broadcast. But here, if you see, I got a reply back. So the target MAC address is 1A:00. The source is this guy, 100020. See the sender MAC address. And the target, it is sent to whom? 10005 for this Kali Linux. So when I did the ARP request, it's not going to the other VLANs. So only within the same VLAN, and there is no gateway. I mean, there is no gateway communication needed here because the ARP request happens within the same domain because this is a layer 2 broadcast and this packet has been generated from VLAN 10. So when I send an ARP request, I got an ARP reply back. And how do you see the additional layer 2 and layer 3 information? I'm expected to see the VLAN ID here, 10005 and 10020. Why we don't see the layer 2 packets here? Okay, fine. Yeah, I'll come back to that. But right now, let's stick to this. So ARP request is a broadcast and ARP reply is an unicast. It's an one-to-one. So before your ICMP packets, what exactly happens? Your ARP packet should be successfully, it should successfully go through all the process. If you don't get an ARP reply back, your ICMP packets will not communicate. And as I said, this is a local broadcast. It is not a broadcast for every network. It happens only in the same network. And when it happens in the same network, you don't need a gateway to respond in the middle. So let's go back now with ARP communication in a different IP subnet. Why we should understand this, I'll come back to this. Whatever the request you do from your computer to any destination across the world, in the whole internet, this is how the whole ARP works. So if this particular computer sends an ARP request and if he is sending back, you got a resolution. What about the 8.8.8? How it works? So it has to go through multiple hops, right? And in every device, the exit interface and the inbound interface of the destination, there will be an ARP request and reply back for it because they are predominantly, they should be in the same WAN segment. So the broadcast happens within the same local broadcast domain. Example, this GI0/1 and Ethernet 1/2, it can't be in a different network. We say it's a WAN connection, right? You connect to a different LAN using this particular LAN interface. So this particular network remains the same. Whatever network that's behind the firewall and behind the switch can be in any network. But the egress and ingress should be in the same LAN, same network. So everywhere the interconnect devices will do an ARP request. That's how we reach we just keep advancing in the routing because of this ARP. So now let's see what happens if it is in a different destination, how this ARP responds for the different destination. Let me now change this to the same port, GI1/3. Let me change this to VLAN 20. Oh, I got it. Why we didn't see this VLAN packets? Because the PC doesn't do anything with the VLANs. We have to take a capture on the switch to see the VLAN information. So this PC can be the same IP address. Let's see how ARP works. We'll do a use case for a non-working scenario. Let's see only the ARP packet. I go to this box and I'll do a ping for a bogus IP address 20.0.0.54. So what I did here, I just tried to ping 20.0.0.54, a bogus IP address. I mean, it's in a different network. So what happens here for my ARP request? Who is sending a reply back here? It's not the actual device. So my gateway responds back. So when a communication is trying to establish from the different VLANs, or maybe you can say from layer 2 perspective from a different network. So VLAN 10 is trying to establish a connection with VLAN 20. So in this case, this broadcast is a local. It can't cross VLAN 10, as I said. So now the default gateway is responding that if you want to reach 20.0.0.2, you're trying to reach 20.0.0.2. So this is my MAC address. You forward to me, then I will do a ARP request again, and we will get a reply back. You can see that in the capture. So continuously, the switch is actually responding for this ARP because this is in a different destination. Because we did a ping to 20.0.0.54. So what if I go ahead and change the IP address of this VPC? IP address 20.0.0.54 255.255.255.0. Gateway is 20.0.0.1. Invalid IP address. What did I do? 20.0.0.54.255. What's wrong? IP address, mask, and gateway. Address, gateway, mask. 200054, right? Let me quickly check this. I'm trying to reach 200054. Two five five 250 20001. So I need no IP address. Long time I didn't use this. How to remove this IP address? You can set like this. Okay, I should not give an IP add. Okay, be 200054. Mask is 255 255 2550 20001. Let's go back to this box and I get a reply back now. So who is telling this? Let's stop this. So this is an ARP request. So you see this is 10005 and it is doing a broadcast. And the target IP actually I'm pinging to 20001, but in the ARP what happens? The actual packet goes to the 10001. And this is the MAC address of the switch virtual interface VLAN 10. And if you see your ICMP packets, ICMP is a direct communication. 10005 goes to 20005. So when you troubleshoot from the, not from the PC standpoint, in if you're doing something with a switch, if you're trying to find, is it my VLAN mapping? And if my routing is fine, let me start the capture here. Capture for 0/3. Why it's happening with this? Capture GA 0/3. Okay, I'll fix this. We don't want to waste our time. So let me stop the sharing. Let me stop recording. So I gave the unmute permission for everyone, so you can ask your questions.
Conversion filter, could you share us the again? Conversion filter, which topic we need to check it again?
Sorry, conversation filter you're talking about?
Yeah. Conversion filter. Which factor I need to focus?
Oh, conversation filter, you have to focus on TCP.
TCP means what exactly? That I was missed actually.
I mean, can you repeat your question?
The
In the conversation is related to TCP. I'm trying to establish a connection from the host to the destination on port 22. So when I'm doing that, I want to see this TCP conversation, so that I'm going to the packet 10.0.0.5, right click on it, conversation filter, and TCP will give me the three-way handshake. Because in the three-way handshake, as I said, you will see your 4-tuple connection. Yeah, from there we have to troubleshoot.
Okay. Okay. Thank you.
I mean, did I answer your question, or maybe your question is different?
Could you share on the screen actually? Because
Okay. Sharing. Yeah.
yeah,
Can you see my screen?
yeah, is visual.
Okay. What is the question?
The conversion filter, how to check that, which parameter?
See, I told you, right? I mean, this is a three-way handshake. The source 10.0.0.5 is trying to establish a connection with 10.0.0.1. 10.0.0.1 is a router. This is the topology. 10.0.0.1, it's a VLAN 10. This port is also VLAN 10. So the communication is happening over VLAN 10. So I have to do a right click,
Okay, then
conversation, and TCP.
okay. Conversation condition.
So here you see your 4-tuple connection, right? Source is 10.0.0.5. Source port is 42554. Destination IP is 10.0.0.0.1. And TCP port equal 23 is your destination port. And here the source resets this connection in this particular capture.
Got it.
Yeah,
Thank you.
okay.
Yeah.
Okay. Yeah.
Yeah. Hi, Praveen.
Hi, Miraj.
Yeah. So for this reset connection, which is coming from the destination, is it directly coming from the destination, or some middle device has sending this response for the reset?
It's actually a good question. See, here, let's go back here. So here, let's take this as an open connection. There is no block. Yeah, this is a successful connection. So you want to focus on the reset of this capture. Let's reset. Okay. So the source reset, I mean, the source has reset this connection, this particular capture, this particular output. Source is telling that I'm going to reset your connection. I can't do the communication for 23. This is 23 coming from what? This is coming from 10.0.0.5 from source 42554, source port, and destination 23. And source is telling that I can't establish a connection. I'm going to reset this TCP connection.
Okay.
Sorry to interrupt you. Sometimes ISP ends getting the drop, okay, or sometimes they reset the packets.
No. This is we'll definitely discuss about that, but we'll just focus on this topic.
Okay.
We don't want to get diverted with a different topic, please. Yeah.
Okay.
With this, if you have any questions, if the scenario, whatever you have, we have a separate session. We'll do a lab and we will definitely will understand that. But is there any question related to this?
Okay. So in this topic, only we are checking layer 2, right? Layer 2.
No, we are doing till layer 4.
Okay.
Yeah. So here the key, we are understanding the key elements. What is three-way handshake and what is reset? And what happens if there is no routing? What is the output I can see in the Wireshark? That's something is the very beginning of the class, and we are mostly focusing on that very key and basic elements of Wireshark. Yeah.
So in there, the TCP flag, what we have to check exactly which parameter we need to focus?
I mean, what is the actual troubleshooting objective in your mind? So that I can answer you better, right? What should focus for what? What kind of issue?
In this bit one, a source to 10.0.0.5 to destination 10.0.0.1.
Okay.
There is a sometime reset the TCP. Okay. So if I will be filter to a TCP flag equal to 1. Okay. In that condition, which parameter we need to focus?
Okay, in the tcp.analysis.flag, tcp.flags equal 1. If you give this, this will give you an output from what do you say? You take this conversation filter. Always start with SYN. SYN, SYNAC, ACK.
Okay.
That's your successful connection. It's a peer-to-peer from source 10.0.0.5 to destination 10.0.0.1 VLAN 10. I send a SYN. This is a port 39418 source port of 10.0.0.5 and destination port is 23. So 21 is used for, 22 is used for SSH, 23 is for telnet. So this is a telnet traffic. So I get a response back, SYN ACK from the server, or maybe from the destination, you would say. 10.0.0.1 is a switch and it sends a SYN ACK back to 10.0.0.5. So if I see these 3 packets, my routing is good. I don't want to concentrate in routing. Correct? My layer 2 and layer 3 communication is fine. So it's going to layer 4, TCP IP. That's how this OSI reference model is about, right? Layer 2, data link layer, network layer, then transport layer, right?
Yeah. So here if I check since ACK and the ECK, right? So if since and the ECK, 2 parameters will be matched, that means the session is completed.
No. See, if you see this particular, the values, TCP segment length, all are zeros. There is no data has been exchanged. If you see this 33 bytes of data has been exchanged here, the packet 4. So in the first 3 packets, there is no data exchange happens. It is a purely 4 tuple connection. Source IP, destination IP, source port, destination port. There is no block. You see a successful 3-way handshake. Even someone is blocking in the middle, you won't see this. If there is a reset, we have to check, is there a firewall or someone in the middle is blocking it, or it's a destination you are blocking it. That's the only possibility, right? Whatever the middle devices you have, it's somewhere blocked in the middle or maybe in the destination level. But you can say my source is good. It's resets is who resets. It's from the destination. So you have to check from the devices from the destination where it is connected to, and do you have any firewalls or anything in the middle who it's actually blocking it. That's a logic, right? You got it what I'm saying?
Yeah, I got it now.
So when you ask me about finishing the whole package, right? So you should see the fin packet. That's actually your successful. It tears down the connection. Here, actually, we didn't do anything with the telnet, a complete telnet. So we didn't see this fin packet because we are just focusing only on TCP 3-way handshake. So in the future classes, yeah, we can see that in the TCP fin packet also. That's a tear down connection between both source and destination.
So here, what is the difference between the length and the TCP segment length, LEN? What is the difference between? So how we can identify the parameters, length and TCP segment length? So what is means? What is the purpose of that tab actually?
1 minute. There is a glitch here. Yeah, tell me.
the length is there, okay,
Okay.
next to the protocol length and the TCP segment length. So what is the difference between them, length and TCP segment length? So generally, yeah.
I got it, but now we are not discussing. I mean, it is a Malhar is your name, right?
No, Vittal here.
Sorry?
Vittal.
Vittal.
Yeah.
Vittal Patel. Okay. No, Vittal Patel. I mean, we'll get back to that. We'll discuss that in detail. Today's topic is not that. I mean, we are just focusing on what is reset, what is TCP communication. Very basic. Yeah. We are doing very basic because this is day one. That takes us to a different topic and it confuses everyone. Yeah. So I want to stick to the course. Yeah, we are doing that. We definitely in the future classes, we will discuss about every single parameters of Wireshark. Yeah.
Praveen, I have one doubt. When we are checking from source to destination, what reason the reset is coming, how to identify this? Say example, one certain cases routing is not be there, or certain cases remote device is not responding. So how we exactly identify what is the reason for reset?
See, if you remember when we did discuss something in the what is that in the whiteboard, if you remember, if you don't have a routing, can you see your TCP connection?
No,
Why?
because it is not 3-way shut will not happen if the routing is not there.
Yeah, if your routing is not there, you can't even come to your layer 4. So if you have your layer 2 and layer 3 configuration properly done between end to end, so then you start looking at your TCP. So that's the first point. Even in the capture, do you see lot of R packets? It's something your R resolution is not happening, then you should focus on that. So example, coming to your point, so my routing is good. And if I see TCP reset, so you're telling why the reset should happen, correct?
Right.
So who is doing the reset? That's the first clue you should take it, right? Do you agree?
Right. Correct.
I think we lost that capture. I think we are filtering only to this. Okay. So who resets this connection here? Can you tell me with this example, who's resetting this connection?
10.0.0.5 is sending to
Reset to 10.0.0.1.
right.
Do you remember why this happened when we did a lab? Okay, I'll tell you. See, example, example, here this client is telling that I'm going to reset this connection. I don't want to continue this TCP connection. So what could be the problem? Either maybe I don't have an application to do that, that particular service, right? If you want to, example, if you open example, how to say that, if you open a HTTPS connection to a particular destination, it works. But when you open a TCP connection to a specific destination, it won't work. Example, if you do HTTPS google.com, it works. But when you do FTP : google.com, it may not work because they're blocking the port. And who resets here? Here the Google resets the connection.
Google,
not client. Yeah, that particular port is not responding to you. So here this 42554 is not responding to 23. Maybe I didn't do a telnet at the right time. I established a TCP handshake. I see a SYN, I saw the SYNAC, but when I didn't do a telnet 10.0.0.1, it will wait. The TCP timer starts and it waits for some time. If I'm not doing anything, then the client is going to send a reset back to him, right?
Right.
So it should be a continuous process and it can be a block in the middle. So that depends on this scenario. So here in this example, we are not blocking anything, but why we saw the reset there? If you remember when we saw the reset there, if you didn't enable the telnet on the switch, when I tried to establish a connection, the port 23 was not open. So when 10005 is trying to establish a connection with 10001, 10001 will reset the connection because I'm not running the telnet service on the switch.
Right.
Yeah. It's that. I mean, what destination is doing it? Who's doing it? Why? The service is not running or blocked. Two reasons. If there is a reset.
Okay.
And what's the reason that source will reset the packet? You show one packet reset from the source.
No, this is a different scenario. Maybe I think we didn't do a telnet at that time. We didn't do a telnet at the right time.
Okay.
Because if it is continuously reset this connection, you can't say this is successful communication on your TCP, isn't it?
Yeah, right.
Yeah.
Suppose when we are reaching to the destination, for example, if the firewall itself is blocking the connection, so how can we see the reset in that case?
So I see, again, I'm telling you have to understand this. TCP is a peer-to-peer communication. So here it is not going to tell you who is actually, I mean, who is exactly resets this connection. It can be the actual client or can be a device in the middle. All you can focus is, example, in this case, if you're telling here the switch resets this connection, where this IP belongs to and how this IP is routed back and forth between source and destination. I can do, in some cases, I can route all this traffic back to the firewall for inspection, and what is allowed or denied based on that, the traffic will be routed back to the switch and comes to the call Linux. Do you agree that?
Yeah.
So if I say a peer-to-peer communication, even though it's a peer-to-peer communication, if your traffic is offloaded to the Palo Alto firewall for the security design or whatsoever you're doing it with the firewall, the purpose is that then if you're blocking something in the firewall, you can just strip out this part and you can focus on your switch and the firewall. Correct. It should be the actual destination or it can be the Palo Alto. But who is resetting this connection? That's important. So you can strip out this part. You can look for your firewall and your actual routing interface VLAN in this case.
So if the firewall is blocking the connection, then with the sync packet itself, we could know that there is a reset coming, right? When we send the sync.
But do you know that is it the Palo Alto is resetting the connection? Do you have any details in Wireshark?
Yeah. In our scenario, we are assuming that if firewall is blocking, so we're not able to get the sync ACK, right? I mean that the handshake will not be happen, right?
See, again, I'm telling, TCP is a peer-to-peer communication, correct? Do you agree that?
Yeah.
The role of the firewall here is to block the port or open the port. It's not doing anything with TCP connection. Do you agree?
Okay, yeah.
So if my port is blocked, it can be a device in the middle that can block that particular TCP connection because that's the purpose of the firewall. It's something in your design. You're routing a packet to the firewall for security reasons. It can be the actual routing device or it can be a firewall. You can check on both. If there is no ACL rules in the switch, if you are managing your network, you can tell the firewall team, right? So I don't have any ACLs in the middle. It's just a traffic routing between this Kali Linux box and the switch. And there is a firewall in the middle. I don't have any ACLs. Can you check is that port opened or closed? This is more granularly, more granular control and you can spot your problem. That's it. You can't exactly tell Palo Alto is blocking it, or you can't say this is a switch is blocking it. You have to work logically and we have to figure out. You have to look for options. But the key point is who is resetting the connection? Is it a client or server? That's more important. That's my point. I mean, if you ask me, that's how I troubleshoot. Here, the client is doing it. Is it the client has this particular communication is being blocked? You have any rules on it? or who is this 10001? It's between 10001 and 10005. Is there anything in the middle who is blocking the connection? Or it is 10001 or 10005. That's how you can figure out. But here it is clearly telling that 10005 is blocking it. So you have to strip out this part and you have to focus only on this box and your switch.
Okay. Yeah, got it. Thank you.
Yeah, no problem. Yeah.
Hey, Pravik.
Yeah. Hi. Yeah.
I have a question. So I can see we are going step by step, and this is like primarily a very initial
And
step.
what is your name?
This is Deepak.
Deepak. Hi, Deepak. Yeah.
Yeah. So my question is like, what exactly will be the content for this whole course? Like how
I
we gonna gradually.
mean,
So there is nothing discussed, or maybe I was not initially there. So just wanna know more about it. Like what will be the
you
content
got
for
the
our
course
mod?
content? Have you got the
No,
course content? Okay.
no, I'm sorry for that.
Okay. So we will send it across. I mean, after this class, we will send this course content to you, over to you. Then you can go through all this topics we have. That gives you a better understanding.
That'll be great. Appreciate it. Thank you.
Yeah, no problem. Yeah. Any questions related to the topic what we discussed so far?
Pradeep, Praveen, this is Sedu here. So,
Hi, Sedu. Yeah.
with respect to the retransmission, under what are all the scenarios or circumstances we are going to see the retransmission? Sometimes, even though there is no firewall block, in some of the Wireshark packet capture, even though, let's say, from source to destination, if the port is 443, but some connections we will be seeing that retransmissions. So just want to understand under what scenarios we will be frequently seeing those retransmission, whether we have to consider those and take an action, or else under which cases we can ignore those.
See, retransmission is actually an expected output, you can see. But what is the amount of your retransmission matters. If you see a capture of maybe if you say 25 meg file, and you see maybe hardly 10, 15 retransmission, that's fine. Because sometimes what happens, there will be a latency in the link. So the packet can't make it to a destination at the right time. So it will do retransmission. But in some cases, you will see the continuous retransmission and your packets will not be forwarded back to the actual destination, the desired destination. So in that case, if you don't have a routing, if something changed in the routing, I would say you should focus more on the routing if there is a retransmission, because it can't make it to the destination. It had a route in the before, and somehow maybe your ISP or maybe a firewall, a misconfigured route, it's mostly with you have to deal with routing when there is a retransmission.
Okay, if there are more retransmissions, the first thing is we have to check on the routing side whether the route isn't properly in place.
Yeah, it is complete retransmission and it is no more the communication is happening. Yeah, definitely it's a route.
Okay, thank you.
And it can be your layer 2 problem and also your layer 3 problem. Even if you have a route and if your layer 2 is not properly designed, then it is again a problem. You have to check both your layer 2 and layer 3.
Okay, sure, thank you.
Sometimes what happens, you will do a route to a destination, but it can be pointing to a different route, different VLAN. So then your packet will not be forwarded to the desired destination, right? So you have to look for your VLAN and routing together for this particular scenario.
Okay.
Praveen, sometime what is happening? Yesterday I was checked with the log. So what I have observed, a few packets are the retransmission, and the remaining all are the good. So what
but
is
the retransmission is happening for the same source and destination, or it's for a different source and destination?
Same source and the destination IP address.
Have you checked the bandwidth utilization in your I mean your edge router or your the edge device.
Because it's not the frequently, but out of means 100 out of only 3 and 4 packets are getting retransmission. So in this case, what is the problem we can consider here?
See, as I said, if you see a communication, then again you see a retransmission. It is because of latency. Even if you have a latency, what happens if there is a no connection at a particular time? It can't transmit the data to the desired destination, right? So it's going to retransmit the data. And if the destination receives this particular traffic, it's going to send an acknowledgement back, and your TCP communication continues. If not, as I said, if you see only a retransmission continuously, then there is a no route to the particular destination. That's the scenario.
Yeah. No, but in this case, packet will be discarded, right? If the randomly retransmission is happening, so packet may be discarded, right?
What do you mean by discard? Sorry, I didn't get you. What do you mean by discard?
Means, for example, I send the 10 packets and around 6 to 7 packets are the retransmission is happening in the log.
Okay.
So what is mean by that?
And you see all the packets are retransmitted or only 6 out of 10?
Only 6 out of 10.
Then you have a routing, right? So you have something problem with the latency. You have to deal with your latency issue here. You are asking me how to find the latency, or what is the exact question you have?
That means how to fix it, because if the routing is issue, then nothing packet will be come is there, right?
That's
But
what I said.
packets
Yeah.
are the, but the packets are the reaching.
There is a latency in the link somewhere. You have to check hop by hop. Every ping, milliseconds, check. Go every router, check in the interface. Do you see any errors? This is particularly, you have to deal with the interface errors and the link configuration, or there any duplex mismatch. If there's an half duplex, your communication has never happened seamlessly. There has always been some drop packets you can see in the queue. You have to check that. Interface level config and troubleshooting, along with that latency.
Yeah, sound good. Thank you.
Yeah, no problem.